July 29, 2025. A massive 8.8 megaquake strikes near Kamchatka, triggering tsunami alerts across the Pacific. Hours later, more than 40 seismic stations from Alaska to California detect synchronized pulses rippling through 14 Cascade volcanoes. An anomaly scientists had never seen. Was this the first warning sign of a planetary chain reaction? This is megaquakes, where distant shock waves awaken dormant giants. What if the real danger has not even started? Seismic monitors across the Pacific Northwest began registering a pattern that defied both expectation and precedent. More than 40 stations, scattered from Mount Baker to Mount Shasta, picked up a series of low-frequency pulses, each arriving at an interval of nearly 11 minutes, each one echoing through 14 separate volcanoes. The pulses persisted for almost 6 hours, their regularity captured in spectrograms that lined up like clockwork across the network. Unprecedented. At 12:17 p.m. Pacific Daylight Time, a sharp, low-frequency pulse registered beneath Mount Rainier's southeastern flank. Automated alert systems flagged the anomaly in real time, sending notifications to USGS volcanologists and regional emergency managers. Within minutes, identical signals appeared at Mount St. Helens, Mount Hood, and the Three Sisters, prompting a cascade of alerts across the monitoring network. Each station's logs recorded the precise timing and spectral signature, ruling out routine background tremor or equipment malfunction. The pattern was clear: a synchronized repeating signal sweeping from north to south along the Cascade arc. Dr. Andrew Forrester, leading the response from the Cascades Volcano Observatory, described the experience as both clinical and surreal. He watched the spectrogram feeds scroll by, each pulse standing out against the usual scatter of geological noise. He later said it was like clockwork, not typical geological noise. The alert workflow moved quickly. Internal messages, flagged logs, and calls to partner agencies. Despite the urgency, there was no evidence of magma movement, gas release, or surface deformation. The data pointed to something new: volcanoes responding in unison to distant seismic energy, not through eruption, but through a kind of planetary resonance. All records, raw waveforms, spectrogram images, and alert logs were archived and cross-checked. Independent analysts confirmed the periodicity and spatial extent, finding no precedent in decades of monitoring. The evidence was undeniable. The Cascades had recorded a historic synchronized pulse event, its signature etched across the region's most closely watched peaks. Instrument logs from July 2025 delivered a clear message. The Cascade volcanoes were pulsing in unison, but none of the usual eruption warning signs appeared. GPS and INSAR readings stayed flat during the entire 6-hour window. Ground deformation, a hallmark of rising magma, was absent. Gas detectors positioned on Rainier, St. Helens, and Hood showed no spike in volcanic carbon dioxide or sulfur dioxide. The air above the summits remained unchanged. Seismic analysts combed through the data, searching for any hint of magma ascent or gas release. Every metric pointed to the same conclusion: these were not the early tremors of an impending eruption. The phenomenon demanded explanation. Dr. Andrew Forrester, reviewing the synchronized pulses, proposed a new frame of reference: volcanic micro-resonance. In his view, the immense pressure waves unleashed by the Kamchatka Megaquake had swept across the Pacific, briefly exciting the natural frequencies of the Cascade volcanoes. He described it as mountains listening or singing, a planetary scale response, not a sign of imminent danger. The pulses, he argued, were the volcanoes echoing distant seismic energy, not preparing to erupt. Colleagues at the observatory weighed in, some calling the evidence compelling, others urging caution. The absence of deformation and gas emissions made micro-resonance plausible, but not conclusive. Skepticism grew as new studies surfaced, A team led by Dr. Veera Patel reanalyzed the seismic records, applying cross-correlation and spectral analysis to the July 2025 data. Their findings challenged the initial reports. According to Patel's group, no coherent 11-minute pulse train could be confirmed across all volcanoes. What appeared to be synchrony might have been overlapping teleseismic arrivals. Surface waves from the Kamchatka quake, not a unique volcanic response. Only Rainier and St. Helens showed any repeating signals, and even those failed to match the predicted resonance intervals. The debate over micro-resonance remains unresolved. Forrester continues to interpret the pulses as a sign of planetary sensitivity, while others caution against overreach. The absence of any eruption precursors, no magma, no gas, no swelling, remains the only certainty. For now, the July 2025 pulses stand as a scientific mystery, their meaning still under review. Mount Rainier's slopes shuddered with over 1,300 small earthquakes in July 2025, the highest swarm ever recorded for the volcano. On some days, the pace soared to 40 tremors an hour, each one too weak to crack pavement or rattle windows, but together, a clear sign that the mountain was restless. The numbers appeared in daily logs, rows of timestamps, magnitudes, and coordinates. Each entry another pulse beneath the ice. Scientists tracked the swarm in real time, mapping clusters and counting bursts. But what caught their attention was not just the data. It was the response downstream. Ording, Washington, a town of 8,000 built on ancient lahar deposits, heard automatic alerts as seismic activity crept above background levels. Phones buzzed with notifications, and loudspeakers on school rooftops tested their sirens. For one family living 3 blocks from the Carbon River, the warning came just after lunch. They gathered their bags, water, documents, asthma medicine, ready to run. Past drills had taught them the timeline. If a lahar broke loose from Rainier's glaciers, they would have 30 to 40 minutes to reach high ground. That window, drilled into memory, was now more than a statistic. It was a countdown that shaped every decision. Should they wait for a second alert? Should they call neighbors or just go? July swarm did not send mud roaring down the valley, but it forced a test of nerves and plans. Emergency managers reviewed their logs, weighing the risks of false alarms against the cost of hesitation. In the weeks that followed, minor quakes flickered beneath Mount St. Helens, Mount Hood, and Mount Adams, and gas monitors picked up brief, harmless puffs. For families in lahar zones, the science of swarms became personal. The numbers on the screen translated into minutes to move, choices to make, and the uneasy knowledge that next time, the countdown might be real. History, no doubt, remains about the power of Cascade volcanoes. On May 18, 1980, Mount St. Helens erupted with such force that the north face collapsed in seconds, unleashing the largest landslide ever recorded. 57 people died. 230 square miles of forest disappeared under ash and debris. The eruption sent a plume around the globe, grounding flights and darkening skies as far as the Midwest. In southern Oregon, the legacy of Mount Mazama is written in the deep blue waters of Crater Lake, a caldera formed by a colossal eruption nearly 7,700 years ago. That blast scattered ash across the Pacific Northwest, reshaping the land and reminding scientists that even dormant peaks can change the region overnight. Threat. Today, the threat is not just history. More than 3 million people live within range of Cascade volcanoes. Modern monitoring networks, run by the U.S. Geological Survey and university partners, form a web of defense. Seismic sensors, GPS arrays, gas detectors, and satellites scan for the smallest shifts, tremors, swelling, new gas plumes. Each sensor feeds real-time data to emergency managers, who rely on hazard maps and evacuation routes drawn from decades of research. Drills and alerts are routine in towns like Orting and Puyallup, where lahar paths cross busy streets. Yet the system faces challenges. Funding for sensor maintenance and network upgrades has lagged behind scientific need. Some deep borehole instruments sit idle, waiting for repairs. Policy debates over federal and state budgets have left gaps in coverage, especially in rural areas where warning time is shortest. Action. State emergency managers urge every family to know their local hazard map, keep an evacuation kit ready, and sign up for alerts. The July 2025 pulses did not lead to eruption, but they exposed how quickly conditions can change. As of early September, all Cascade volcanoes have returned to background activity. But the lesson is clear. Preparedness is not optional. Supporting science and emergency planning is the only way to turn warning time into action. The next eruption is a matter of when, not if. Today, over 10 million people live within reach of Cascade volcano hazards. As global seismic networks grow, the uncertainty remains. We can detect every tremor, but we cannot predict the next eruption. For the Pacific Northwest, readiness is not a choice. It is what stands between risk and disaster.